Hello everyone, today in this video we'll be discussing the second module of BCS301 Maths of third semester. So in this module we have mainly three topics which are asked from the exam point of view. So the first one is the joint probability distribution, inside which we have a few subtopics. So they can ask you any of these questions. So we'll be discussing how to solve them, what's the formula, and after that we have stochastic matrices and Markov chain. Okay, so without wasting more time, let's get started. Before starting, make sure the like button, subscribe my channel for more videos like this, and make sure watch this video till the end. Easily you can score more than 80% marks if you follow all the steps which I have mentioned in this document. So let's get started. The first one is the joint probability distribution. Okay, so some things you need to remember here. Okay, just listen to what I say. Two rules are here. Okay, so probability of x and y should be greater than 0. Like x and y, there will be a combination and there will be one value. That probability should be greater than or equal to 0. Okay, and the summation of all the probabilities of x and y should be equal to 1. Okay, so let's understand this using the table. Okay, so this is a joint probability table. Here we will be having the x values in the row side and the y values in the column side. Okay, so here we have been given x1 x2 x3 till xn, and here it is y1 y2 y3 y3 till yn. Okay, after that in the last column you can see there is a m density here. Okay, m density of x. Okay, so what is m density? M density is the margin density. Okay, what do you mean by margin density? So to calculate the margin density of this one of x in the first row, see, this is the x1, right? So we will get the margin density of the x1 here, and what is that equal to? That is equal to the probability of this plus probability of this plus probability of this till end. Okay, if you calculate all these probabilities and add up them, then you will be getting px1, and that is the value of the mass density of x1. Okay, like that for x2 x3 till xn you can calculate and keep it here. These are the individual mass marginal densities for the x value. Similarly for the y values also we have. If you want for the y1, just calculate all these values sum and store it here, and calculate all these values sum and store it here. This is the mass density value of y2 and so on till yn. Now if you add up all of these values, or if you add up all of these values, that value will be 1. Okay, so the summation of all these marginal densities of x is equal to 1, and summation of all the marginal densities of y also equals to 1. Okay, so let's understand what is the independent variable. Independent random variable will be probability of xi and yi is equal to probability of x multiplied by probability of y. If the above is true, then the variables are independent. If this is true for all x and y in the whole table, then it will be called as independent random variable. Okay. Now, what is expectation, variance, covariance, and correlation? Okay, expectation is nothing but the mean value which we studied in the previous module. E of x, that is nothing but the summation of x into p of x. Okay, and variance is nothing but sigma square, that is the summation of I to n xi minus the mean value whole square multiplied by probability of xi, or it can also be written as the e of x square, which is nothing but the expectation with x square values minus expectation of x whole square. Okay, that way you will get the v of x value. Standard deviation is nothing but the square root of v of x, square root of variance, and covariance is nothing but e of xy. Like how we calculate the expected value of x, like that we'll calculate the both together, and we'll be subtracting with the new x and new y, which is nothing but ex into ey. Okay, and coefficient of correlation, that is also defined as covariance of xy divided by the sigma value of x into sigma value of y, which is a standard deviation of x into standard deviation of y. So when we do the problems, you'll understand more clearly about these formulas. Okay, so let's get started with the first problem. The first problem is the joint distribution of two random variables x and y is as follows. Okay, so two random variables are there. Which are those variables? X and y. So the joint distribution is given as follows. This is the x values and these are the y values. So what is the probability of 1 and -4 occurring together is 1 by 8. 1 and 2 occurring together is 1 by 4, and so on. Like that, it is all written here. Okay, this is called as joint probability distribution. Now what they have asked is find out the marginal distributions of x and y. Okay, so this is the x values and this is the y values. For marginal distribution, what we do, we add another column here, and for each of these we have to store some values. Okay, how we will store this value and this value here? add up all of these and write here, add up all of these and write here. That is the marginal distribution of x. For y you will do the same thing, you will make another row here, and here you will be writing the summation 1 by 8 plus 1 by 4 here, 1 by 4 plus 1 by 8 here, 1 by 8 plus 1 by 8 here. Okay, so that is the marginal distribution of y. For covariance of x and y, we will be discussing how we will be doing that. Okay, so let me show you about the first question, marginal distribution of x and y. Okay, so when px is equal to 1, add 1 by 8 plus 1 by 4 plus 1 by 8. That will be equal to 1 by 2. Okay, so this is the values which you have here, 1 by 8, 1 by 4 and 1 by 2. Okay, so add up these three values and you will be getting one value, that is a marginal distribution of x is equal to 1. And x is equal to 5's marginal distribution, 1 by 4 plus 1 by 8 plus 1 by 8. Okay, so that is what written here, 1 by 4 plus 1 by 8 plus 1 by 8, that is equal to 1 by 2. Like that, y also you can do. For y is equal to minus 4, the value will be 1 by 8 plus 1 by 4. For y is equal to 2, it will be 1 by 4 plus 1 by 8. For y is equal to 7, it will be 1 by 8 plus 1 by 8. Okay, so this is how you calculate the marginal distribution. After that, you can depict it like this. For xi, when it is 1, the marginal distribution is 1 by 2. When it is pi, the marginal distribution is 1 by 2. For y, it will be minus 4 is 3 by 8, 2 is 3 by 8, and 7 is 1 by 4. Okay, that was about the marginal distribution. Second, what they have asked. The second question is to calculate the covariance of x and y. Okay, so what is the formula for covariance? We discussed about the covariance of x and y is exy minus nu x nu y, right? Let me show you the formula. The formula is this one, covariance of xy. So for that we need the expected value of xy, nu x, nu y. These three things we need. So let's calculate each of these. For exy, we need the values of x into y into p of xij, and this value is nothing but e of x, and this value is nothing but e of y. Okay, so let's calculate those three values. First, e of x, how you will calculate? To calculate e of x, you need the marginal distribution value. Okay, you will multiply xi with p of xi with p of xi, 1 into 1 by 2 plus 5 into 1 by 2, right? That will be 3. Now for y also same thing, minus 4 into 3 by 8 plus 2 into 3 by 8 plus 7 into 1 by 4, that will be equal to 1. Ex is nothing but nu x and ey is nothing but nu y. We have got these two values. Let's calculate e of xy. E of xy will be calculated as xi into yj and probability of xi yj. For this one, we need the joint probability distribution table. So let's understand when the first value is there. This is xi and yi into probability of xi yi. 1 into 4 into 1 by 8. Okay, so 1 into 4 into 1 by 8. So here in the probability distribution table, joint probability distribution, this is there, right? 1 into minus 4 into 1 by 8. Okay, sorry, it is minus 4, we have to take it as minus 4. Okay, 1 into minus 4 into 1 by 8, we will get one answer. Add it with 1 into 2 into 1 by 4. Add it with 1 into 7 into 1 by 8. Add it with 5 into minus 4 into 1 by 4. Add it with 5 into 2 into 1 by 8. Add it with 5 into 7 into 1 by 8. Okay, so when you do that, you will be getting the e of xy. Okay, e of xy together, it will be this answer. Here it is minus 4. Okay, just make the correction. So you'll get an answer here 3 by 2. Okay, what you will get here answer 3 by 2. Okay, so this is the value of exy. We have the value of nu x and nu y calculated here, 3 and 1. Just substitute these values and calculate. Your answer will be minus 3 by 2. Okay, so this is how you calculate the covariance. Next, what they had asked the sigma x and sigma y, that is nothing but the standard deviation. It is nothing but the square root of variance of x, square root of variance of x and square root of variance of y, right? So let's have a look at that. What is the square root of variance of x? Okay, so also we can use this formula here, e of x square minus nu x whole square. Okay, so sigma x square is nothing but the variance. Okay, they have not asked standard deviation, sorry, they have asked the variance. Okay, so after variance, we'll be calculating the standard deviation. Okay, so first we need to calculate variance. So how do we calculate variance? The formula is e of x square minus nu x square. Okay, so this is the formula, e of x square minus nu x square, and for y we will be having e of y square minus nu y square. Okay, so how do we calculate e of x square? It is nothing but xi square into p of xi. Like previously how we calculated e of x, it will be x into p of xi, right? Here it will be x square into p of xi. So before multiplying with pxi, just do the square of x. Okay. So the for the first one, it will be 1 square into 1 by 2 plus 5 square into 1 by 2. So it will be 13. And for y square, it will be the corresponding y values. It will be 4 square, 2 square, and 7 square. Okay. So it will be 79 by 4. So this is the value of e of x square, and this is the value of e of y square. Subtract it with ux square and uy square. Okay. So ux square previously we had got 3, and uy square we had previously got as 1, which is nothing but ex and ey value, right? Ex in ey, what we got? Ex is 3, which is new x, and ey is new y, which is 1. So 3 and 1 are the values of new x and new y. So just substitute the values of new x here and new y here, and you'll be getting the value here as 4 and 79 by 4. Now you have to calculate the standard deviation, which is sigma x and sigma y. So you'll just take the square root. So if you take the square root of this one, you will be getting 2. If you take the square root of this one, you will be getting 4.33. Okay, that is how you calculate the values of the standard deviation. Next, they had asked the correlation. Okay, what they had asked, correlation between um, the x and y, right? Correlation of x and y. So what is the formula for correlation of x and y? Okay, so the formula is correlation of x and y is given by rho here, and covariance of xy divided by sigma x sigma y, which is nothing but standard deviation value. We have all these values. Covariance is nothing but minus 3 by 2 in the previous sub question we had solved, and sigma x and sigma y also we have got 2 and root 75 by 4. When we multiply this and simplify, we'll be getting the answer as 0.1732 minus 0.1732. So this is the correlation value. Okay. Next, this is one type of question, type 1 question, which I discussed. Like this it can be asked. And the second type of question is this one, independent random variable type questions. Okay, so the question will be like this: x and y are independent, so they have explicitly given it is independent. Okay, and x takes the values 257 with probability 1 by 2, 1 by 4, 1 by 4. Y takes 345 with probability 1 by 3, 1 by 3, and 1 by 3. And the question is, find the joint probability distribution of x and y. So this is the marginal density values they have given. We have to calculate the joint probability distribution. Show that covariance of x and y is equal to 0. Also covariance of x comma y will be equal to 0, we have to show. Okay, let's discuss the first one. So let's first construct the table x with these values and y with these values. Okay, so this is the data which is given to us, x with these values and y with these values. These are the marginal values, and now we have to calculate the joint probabilities. How do we get the joint probabilities? The formula is this one: p of xy is equal to p of x into p of y. Now this is the formula which is used in the independence random variables, right? They have given it is independent random variable, so the formula will be p of xy is equal to p of x into p of y. Now p of x is this one, and p of y, whichever we take, it is this one. Suppose that we want to calculate 2 comma 3, so it will be 1 by 2 into 1 by 3. If you want to calculate 2 comma 4, it will be 1 by 2 into 1 by 3. If you calculate 5 and 5, suppose it will be 1 by 4 into 1 by 3, like that it will be. Okay, so like that we'll multiply here and get the answers. So the answers will be in this form: 345, 257, and the multiplied answers will be here. If you add it up, you will be getting 1 by 2, 1 by 4, 1 by 4, and if you add it up in the column wise, you'll be getting 1 by 3, 1 by 3, 1 by 3. They had given this one to us, these two things they had given, and we calculated this one. Okay, and if you add up all of this, or you add up all of these, you will be getting here 1. Okay, so this is how you calculate the value of the joint probabilities. Okay, from the marginal values you are calculating joint probabilities. This is the reverse of what we did in the previous question. In previous question they had given joint probabilities, we calculated these two values, right? Now moving on, we have the second one, which is show that the covariance of x and y is equal to 0. So tell me, what is the formula of covariance? So covariance of x comma y is equal to, it is e of x square minus new x new y, right? E of xy, okay, not x square, e of xy minus new x new y. Okay, so this is the value of covariance. E of xy we have to calculate. For that we will be having to apply the formula xy into p of xy, and new x is nothing but ex xi into p of xi. You have the table which is given, the marginal distribution table. From there, 2 into 1 by 2, 5 into 1 by 4, 7 into 1 by 4. Okay, this one we have to refer not this table, we have to refer this table. Okay, this table, 2 into 1 by 2, 5 into 1 by 4 plus 7 into 1 by 4. This way we will get the new x value, and new y value how we will get 3 into 1 by 3 plus 4 into 1 by 3. After you got new x and new y values, calculate the value of exy. Exy is given as x into y into probability of xy. For this we need this table. Okay, you have to calculate 2 into 3 into 1 by 6 plus 2 into 4 into 1 by 6 plus 2 into 5 into 1 by 6 and so on. Like that we have to do. Okay, so we'll do for all the 9 cells. This is the first 3, second 3 and third 3, and we'll be getting the value here. This is the value of exy. Now substitute the values. Exy minus new x into new x was 4, new y is also 4, exy is 16, 16 minus 16 is equal to 0. Hence the value which that asked to proven, it is proven. Okay, these are the two types of question which can be asked from the joint probability distribution table. Okay, so make sure you know this very well. Moving on to the second topic, which is stochastic matrix. So let's understand some basic concepts. What is a vector? The first one is vector. Vector is a tuple of numbers from v1 to vn, where quantities v1 to vn are called components of the vector. This whole thing is called what? This whole thing is called vector. And each of these v1 and v2 and all these are called components of vector. Okay. Next, we have to calculate the probability vector. What do you mean by probability vector? Probability vector is a vector in which each component represents the probability of an event. Here it will not be whole numbers, it will be in the form of probabilities, like 1 by 10, 1 by 2, 3 by 4, like that it will be probabilities. Okay, and the um, also it will be having some rules. The rule is that each vi is non-negative, the probability should not be negative, and the summation of all probability should be equal to 1. These are the two rules. Now let's understand with an example. See, this is the first vector table given to us: 1 by 4, 1 by 2, minus 1 by 4 and minus 1 by 2. If you add up all of these, this is coming to be as 0, right? Why? Because the value is negative here. Negative should not be there. Because of negative, it will come as so it will not come as 0, it will come as 1 only. 1 by 4, 1 by 4 will cancel, 1 by 2 plus 1 by 2 is 1. But the second condition, which is the non-negative, it should not be having any negative. So it is not a vector. And probability vector, it is not a probability vector. 1 by 2, 0, 1 by 3, 1 by 6, 1 by 6. If you add up all of this, you will be getting not equal to 1. So it is not a probability vector, even though there is no negative element. In this case, there is no negative element. Also 1 by 3 plus 1 by 6 plus 1 by 2 will give you 1. So it is a probability vector, valid probability vector. Okay. Next, what is a stochastic matrix? A stochastic matrix is a matrix which is a square matrix. These three rules should be satisfied. It should be a square matrix. Each entry should be non-negative, and sum of entries in each row should be equal to 1. So row sum we will find here. Okay, we are not concerned about the column sum. We are concerned about only the row sum, this sum and this sum. Okay, so let's understand this one. In this case, we have 0 plus 1 plus 0, sum is equal to 1. 1 by 2 plus 1 by 4 plus 1 by 4, that is also equal to 1. So is this a stochastic matrix? No, it is not, because only 2 rows and 3 columns are there. 2 cross 3 is not equal to square matrix, right? It is not a square matrix, so this is not a stochastic matrix. This is a square matrix. Sum is 0 plus 1 is 1. 1 by 2 plus 1 by 4 is not equal to 1. 1 by 2 plus 1 by 4 is not equal to 1. So it is not a stochastic matrix. Here we have a square matrix. Good. 1 by 2, 1 by 4 plus 3 by 4 is equal to 1. 1 by 6 plus 5 by 6 is equal to 1. Then it is a stochastic matrix, and each of these element is a element greater than or equal to 0. Okay. So this is also important. Next, this is how you calculate the stochastic matrix. Now we have another similar concept, which is regular stochastic matrix. What is a regular stochastic matrix? You have been given the stochastic matrix. How we will know if it is regular? If you multiply it with itself, like a square, we'll be getting all the values greater than 0. None should be 0. Until we get it as all the values not equal to 0, we have to multiply it with itself. Now again, we'll be multiplying a with this one. Okay, so 0, 1, 1 by 2, 1 by 2. We'll be multiplying this with a. Again, we'll be getting a cube. Again, we'll be multiplying with a. In case we got 0, again a4. Like that, we'll keep on doing until we get the values all non-zero. If you don't get, it is not a regular stochastic matrix. Now there are some properties of a regular stochastic matrix. P is the matrix. It has a unique fixed point x such that x into px is equal to x. If you multiply x with p, you will be getting back x. Okay, and p has a unique fixed probability vector such that vp is equal to v. Okay, vector multiplied by probability, it will be equal to the v, and summation of all the vectors in the same row will be equal to 1. P square, p cube, and so on approaches to a matrix V, where each row is a fixed probability vector. Okay, we will reach a point if we keep on taking the uh, uh, multiplying it with itself, we will reach a matrix V where the probability vector will be the in each row. Okay, this will understand which will discuss in the when we will discuss the problems. Let's have a look at the problems. The expected questions which you can expect, like what type of questions, these are the type of questions. Okay, so find the unique fixed probability vector for the regular stochastic matrix. They have given it is a regular stochastic matrix. Okay, now we have to find out the fixed probability vector. So what's the formula? Here we have been given with a, and we have to find out v. This is the fixed probability vector. Okay, how many rows and columns are there? 3 cross 3, so we'll be taking 3 elements here, and v1 plus v2 plus v3 is equal to 1. This is the rule in the probability vector. So always the vectors component sum will be equal to 1. Now va is equal to v. Okay, v multiplied by a matrix is equal to v. By using this, we have to form some equations. What will be the equations? If you multiply this, it will be v1 into 0 is equal to 0 plus v2 into 1 by 6, which is equal to v2 by 6, plus v3 into 0, which is equal to 0. So v2 by 6 is equivalent to this one. Okay, whatever answer we got in the first multiplying this one and this one, that is equal to v1. So v1 is equal to v2 by 6. Moving on to the second one here. For this row, v1 into 1 is v1 plus v2 by 2 plus v3 into 2 by 3. Okay, so v1 plus v2 by 2 plus 2v3, this value is v2. Okay, so and similarly for v3 it will be v1 into 0 is 0, v2 into 1 by 3 plus v3 into 1 by 3. So v2 plus v3 by 3 is equal to v3, the third one. Okay, so these are the system of equations. When we take a sample value, like suppose v1 is equal to 1, if we take v1 is equal to 1, we will be getting the value of v2 which is equal to 6. If we substitute v1 and v2, then in this equation we will in this equation we will be getting the value of v3 which is equal to 3. Now we have got v1, v2 and v3, but we need the probabilities, right? So 1, 6 and 3. If you want the probabilities, what you do, 1 plus 6 plus 3 you do, you will be getting some value which is 10. The you will divide each of these values by 10, so it will become 1 by 10, it will become 6 by 10, it will become 3 by 10. Okay, like that you have to calculate the probability vectors. Now after you calculate the probability vector, this is your final answer. Okay, that's what they had asked in the question, to calculate the unique probability vector, right? See, that's the question they had asked. Find out the unique probability vector. So this is how you like solve these questions related to the stochastic matrix, regular stochastic matrix, under the topic stochastic matrix. Moving on to the third topic, which is the Markov chain. Okay, Markov chain rule. Okay, so I'll directly discuss it with a question, because if I explain you the formulas and all, it will be a bit confusing. So let's understand with this example. If you listen carefully to this example, this one example should be sufficient for you for the understanding the whole concept, what it means. Okay, Markov chain rule. So listen carefully. Every year a man trades his car for a new car. Okay, so there is a man here and he has one car. Okay, this is one car here, and he trades it for another car. Okay, another car he will be trading it for. Okay, so if the car is Maruti, if he has Maruti, he'll trade for Ambassador. Okay, if he has Maruti already, he will sell Maruti and buy Ambassador. Okay, if he has Ambassador, he trades it for a Santro. Okay, if he has Ambassador already, he'll sell Ambassador and buy Santro. Now if he has a Santro, he'll just as likely to trade it for a new Santro as to trade it for a Maruti or an Ambassador. Okay, so either he will be selling it for the Maruti, or he will be selling it for the Ambassador, or he will again buy a new Santro. Okay, so it is given us that in 2000 he brought his first car, which is Santro. So first, which car he had? He had a Santro. Okay, these are the information given to us. Now find the probability that in 2002 he has Santro, in 2002 he has Maruti, and in 2003 he has Ambassador. Okay, and in 2003 he has Santro. Let's calculate that. Okay, and also in the long run, what is the probability that he will have Santro? For that probability also we will calculate what he will be having in the long run. What is the probability that we will calculate? Okay, so first step, define three states. They have given three cars, so define three states: A1, A2, A3. A1 is the state of having a Maruti car, and A2 is a state of having Ambassador, and A3 is a state of having Santro. Okay, Maruti, Ambassador, and Santro. Okay, so these three cars are there, denoted by M, A, and S. Okay, so then space I will be defined as A1, A2, A3, which is Maruti, Ambassador, and Santro, which is MAS. Okay, now we have to calculate the transition probability matrix. Okay, so in Markov chain rule we have to calculate transition probability matrix. Now P is a transition probability matrix. Here we have written A1, A2, A3, A1, A2, A3 based on the rules. What is A1? A1 is Maruti, and A2 is Ambassador, A3 is Santro. Now if he has a Maruti, will he buy another Maruti? No. If he has a Maruti, will he buy a Ambassador? Yes. The question it is given, right? If he has a Maruti, he will be selling it for Ambassador. And next is, if he has a Maruti, he will buy Santro? No. If he has a Ambassador, he will buy Maruti? No. Ambassador with Ambassador? No. Ambassador for Santro? Yes. It will be 1. Now, if he has a Santro, will he buy Maruti, Ambassador, or Santro? The probabilities are equal, so it will be divided by 3. Each will be 1 by 3. So this is the matrix you have to generate by reading the question. It is called as transition probability matrix. Okay. Now, in 2000, initial state we will be considering from, that will be equal to P0. That is the first state what he had, MAS, was 0, 0, and 1, because he had a Santro, right? So we will be writing 0, 0, 1. Next, in 2001, what will be the case? Let us find P1. How we will calculate P1? We have to multiply this value with this. P0 with P. 0, 0, 1 with this. We will get another value here. 1 by 3, 1 by 3, 1 by 3. So after 1 year, you will be having either Maruti, Maruti, either Ambassador, either Santro. Okay. 1 by 3, 1 by 3, 1 by 3. Okay. So this is the value we got, P1. Now, we have to calculate for 2002, because in the question they are asked for 2002 and 2003, right? So 2002, how will calculate? Multiply this value with P. Multiply this value with the initial P we had. If you multiply, you'll get this one: 1 by 9, 4 by 9, and 4 by 9. Maruti, Ambassador, and Santro. So the probability that he has a 2002, in 2002 he has a Santro, is 4 by 9, and the probability of he having Maruti in 2002 is 1 by 9. Okay, so it will be 1 by 9 and 4 by 9. Okay, next is in 2003 also they are asked, so we have to calculate P3. It is nothing but P2 into P. P2 multiplied by P, we will be getting an answer which is 4 by 27, 7 by 27, 16 by 27. The question was 2003 he has Ambassador, so Ambassador is this 7 by 27. 2003 he had Santro, which is 16 by 27. So 7 by 27 and 16 by 27 is the answer. Okay. For long run probability, they had asked, right? For the long run he will have a Santro. What is the probability? We have to calculate the probability vector. Remember how we calculate the probability vector? We have taken V1, V2, V3 such that Vp is equal to V, and summation of Vi is equal to 1. Summation of all the vectors should be equal to 1, and if you multiply the vector with the probability, the matrix, we'll be getting V only. Okay, so these are the two rules. So V1, V2, V3 into P should be equal to V1, V2, V3. Also, the summation of V is equal to 1. So V1 plus V2 plus V3 is equal to 1. Solving these equations after multiplying them and simplifying it, we'll be getting these values: 1 by 6, 1 by 3, and 1 by 2. Just as how we discussed in the stochastic matrix, we multiplied and simplified, right? We got the values here. By assuming some values, we'll find out the other values. The same thing we'll be doing here also. So these are the values. So they have asked us about the Santro. So we have to take this value. What is the probability that we will have a Santro in the long run? It is 1 by 2, which is 50%. Okay, that's all for this video. If you found this video helpful, please do like and subscribe. It helps me make more videos like this. And thank you so much for watching. I'll see you in the next one.